welcome back to the Intro to Machine Learning series by ISTE. We'll be continuing our discussion on decision trees. Now we'll be looking at attribute selection measures. The first one we'll be seeing is the information gain. It's commonly used in the ID3 algorithm. And the second one we'll be seeing is the Gini Index, commonly used in the CART algorithm, classification and regression trees. Now for the information gain. The definition is information gain tells us how much information a feature tells us about the class. So at every node, we want to be more certain about what the final output will be for its children. And to first understand information gain, we need to see one property called entropy. And entropy is defined as the negative sum of p of x log p of x. And here p of x is a fraction of examples in a given class. So we'll see what this p of x is in the next slide. Say we have a node which has 8 children, AAA and BBB. For the set x, the total instances A, instances of B is 5, and instances of A are 3. So the entropy of x is defined as negative sum of p of A, which is 3 by 8, log p of A plus p of B log p of B. And substituting the values, we get our answer. The entropy of x is given as 0.954. Entropy is a measure of the disorder or uncertainty, and the goal of machine learning models and data scientists in general is to reduce uncertainty. So we want to reduce the entropy. Now, information gain. Why does it matter? Information gain is the main key that is used by decision tree algorithms to construct a decision tree. Decision tree algorithms will always try to maximize information gain. An attribute with highest information gain will be tested split first. So we always want to maximize information gain. That's a key point, always remember it. An attribute with highest information gain will be tested / split first. Remember that. The information gain formula. We simply subtract the entropy of y given x from the entropy of just y to calculate the reduction of uncertainty about y given an additional piece of information x about y. This is called information gain. So what we do is define information gain is we have entropy of y and we subtract entropy of y given x from it to find information gain. Gini Index. Now the next parameter that we'll be looking at is Gini Index. These are just attribute selection methods, and this defines how we split the tree. Generally, we don't need to know much about the maths, but it's always better to have a good understanding so that we know which measure to use. Here, Gini Index is a metric to measure how often a randomly chosen element will be incorrectly identified. It means an attribute with lower Gini Index should be preferred. Okay? Remember that. For information gain, we had an attribute with the highest information gain will be tested / split first, and here an attribute with lower Gini Index should be preferred. Okay? The formula for Gini Index is 1 minus summation of p of I, the whole squared, summation from I equal to 1 to c, where p of I is the probability of an object being classified to a particular class. Okay? P of I is the probability of an object being classified to a particular class. And that is it for attribution selection methods. Now quickly we'll see some other concepts related to decision trees. Recursive binary splitting. In this procedure, all the features are considered and different split points are tried and tested using a cost function. Split with the best cost or lowest cost is selected. So yeah, generally in machine learning algorithms, we want to reduce our cost. And the key to this is knowing how to split and how to produce our decision tree, which we want our model to learn automatically using factors such as Gini Index or information gain. Pruning, now a method to improve the performance of a tree. The performance of a tree can be further increased by pruning. It involves removing the branches that make use of features having low importance. This way, we reduce the complexity of a tree and thus increasing its predictive power by reducing overfitting. Pruning continued. Pruning can start at either roots or the leaves. The simplest method of pruning starts at the leaves and removes each node with the most popular class in that leaf. This change is kept if it doesn't deteriorate accuracy. It is also called reduced error pruning. A more sophisticated pruning methods can be used, such as cost complexity pruning, where a learning parameter alpha is used to weigh whether nodes can be removed based on the size of the subtree. This is known as weakest link pruning. So you can search more on cost complexity pruning later. In our next video, we'll be looking at how to implement decision trees in Python, and we'll be looking at models with Gini Index and with information gain. We won't be doing pruning, but I highly encourage you to research about cost complexity pruning and check it out when you're free. So that's all we have for today's video. In the next video, as I mentioned, we'll be looking at the Python implementation. We'll be using a diabetes dataset, which has different parameters which could indicate whether a person has diabetes or not, and more on this in the next video. So that will be all for now. Hope to see you there.